Does it say check for question 8 and 9 and what you would do?
Yeah, it says why are there not details on step 8 and 9? What actions are you going to take?
Okay.
Let me guess. You guys are reviewing something related to our
Yes.
our plan, huh?
We were discussing. I got 50% grade on the design the study section for the final project, and it was referring to this point 8 and 9. The instructor is advising us to review it, detail a little bit more, and then just resubmit.
Okay, so where did you find this? I haven't even began to look at that. So
Yeah,
I just went into grades and checked for the feedback for that specific point.
yeah, I haven't even begun.
Just check on grades for the course and then went to the final project section.
Okay. Okay.
So are you getting the same than us?
Yeah.
Right. I think we can discuss that a little bit and then we can resubmit that one.
See if I can get it to open up here. Study. I thought there was. All right. I guess if you guys are ready to start with the other, we can discuss this afterwards.
I just pulled up the thing, and there are for questions 8 and 9. You did have something under those. I don't know. I don't know if you wanted more details on those or what.
I think so, because we just wrote down in that section on 8 that we will be using the systematic sampling. And then for 9, it says that we will select local grocer and select the first container on the shelf, and every third one that after unit will have a sample size of n equals 30 for each location.
I'm wondering if okay.
Question 8, I don't know what more information you would need for question 8. I think, I don't know, but obviously it sounds like he wants more.
And in reality, because it's a direct question, which sampling method will your group use? It's the systematic sampling. I think, I don't know if the instructor was able to say it. I mean, it's because it was just having no space within the paragraph or question 9. I don't know, maybe.
That could be just the way it looks on there. It almost looks like it's part of question 9.
Yeah, that could be one thing. But then because there is nothing else that we can describe about that method, because question 9 is asking us how we will be doing it.
All right, we can talk about that, I guess.
The only thing I can think of more with 9 would be, just talking about counting them and getting the information from counting them.
Yeah, we can add that.
Okay. So if I understood you correctly, the way that it was without the spaces there, systematic sampling will be applied. Looked like it was tied to question 9, correct?
I think so. Mm-hmm.
That's the only thing I can think of with that one.
Maybe.
Then for 9, as Kira was mentioning, we can add maybe that we will be counting, all the broken chips that we will be having. And from there, we will get our sampling.
I thought we mentioned that, but I guess we'll have to. Okay.
I think on there it just talks about getting the container of them. It doesn't talk about the actual counting of the individual chips.
And where does that need to go?
On number 9, the description which is on there is great. Just will be to add that we will be counting every single chip to count how many broken chips we have in each container. So in the end, we can come up with the conclusion of if the deliverance or shipping it's having, yes, if the shipping distance it's having any difference in the broken chips that we're having from the 3 different populations.
Mm-hmm.
Because what the feedback says, it says, why are there not details in step 8 and 9? What action are you going to take at conclusion of experiment? Please resubmit. So I think it's looking how we're going to do with the data that we will be getting.
I don't know. I'm not trying to cure cancer here. I'm just trying to meet the assignments for class.
Right.
It will be just to add extra details on it. I'm fine with it, just adding extra details.
Write a letter to the Pringles manufacturer indicating our findings and yeah. So we'll count each chip in each container, noting the number of broken chips.
Yeah.
Mm-hmm.
Okay.
Mm-hmm.
So is that going to be the proportion? Is this, I guess, does that turn into a proportional one? If we have, let's say hypothetically, there's 50 chips in each one and we're looking for the proportion from each, or just each sample is going to be 50 chips?
Yeah, I don't think it's a proportion. I think it's just the number of broken ones.
Correct.
So the total number of chips isn't important. It's the broken ones compared to whole, or just the broken ones, correct?
Yeah.
I think so, yeah.
Okay. Okay, anything else?
I think it's fine, those details.
Yeah,
So-
thank you. Add those.
Did we need to add anything else to number 8? Which sampling method will you use?
I think just with the name, that is sampling method, because that's what a question is asking. I mean, it's
Yeah.
just instructions.
All right. So I guess the last question is he wants to know, I'm not, sorry, I'm not looking at what the feedback was again. So feedback.
It says just, what action are you going to take at conclusion of experiment?
I don't know what's from that.
Okay.
I think there is no specific action that we can take, just to verify if the shipping procedure is having any difference in the, I don't know, the quality of the product at the time the client is just purchasing it, having the amount of broken chips into the container, maybe.
I'm just going to put down, if at the end we find there's a difference in the amount of broken chips in either location, we will draft a review of our findings and notify the Pringles company. How's that?
Just to notify them that the shipping distance, it's having an impact on the product quality.
Sounds good.
Our study found that there was a shipping distance has an impact on their product.
Yeah.
Right. We can resubmit that this evening. Save that and we'll call that draft 3. Okay.
Okay, thank you. So I think we can move on with the review that we have for tonight.
Okay. All righty. Excuse me.
Okay, fine. Okay, so we have 38 questions to go through the review. And then that says for number 1, question 1 through 4. We have the list of all the studies that we can make. And one says, in an article in the Journal of Small Business Management, successful startup businesses in the United States and Korea were compared. One set of data compared educational level, high school, undergraduate degree, master's degree, doctoral degree of people who manage successful and startup companies in the United States and Korea. You want to determine if education level differs between managers of successful and startup companies differs between these two countries. Which hypothesis test would be most appropriate for this analysis? I was selecting the independent sample t-test.
That's what it sounds like to me.
Because we had two different locations.
Right.
It had two different locations, but there's so many different education levels. So I mean, I'll be honest with you, I'm confused on this one because there's two different location levels or areas, what is it that's truly trying to monitor the?
I was going with this option because the question says in the end, you want to determine if education level differs between managers of successful startup companies differs between these two countries. I was going with that one because the question is just including the two countries.
Right.
And startup companies. I know at the beginning it mentioned the different levels of education that are taken in hand, but in the end it's going with the question evaluating as the two countries.
Yeah, I agree with it. It's like the sample when they were figuring out the grades. So there was, the different grades, but they were just looking for the.
So you guys believe that it's D, independent sample tests?
Yes.
That's what I think. I'm not positive, but
okay.
Okay, so number 2, a human resources manager reported data from a recent involuntary reduction in force at her company. You are an attorney and want to determine if age discrimination was a factor. It is illegal to discriminate against employees because of age. The company reported the number of employees in 2 groups, 40-year-old and younger and over 40-year-old. They also reported the number of employees in each group who were terminated. You want to determine if both age groups were treated equally. Which hypothesis test would be most appropriate for this analysis? So would this be the test of 2 proportions? Are you trying to figure out what proportion of them?
I thought this was the independent sample.
With that one, I was thinking it was the paired sample t-test or the test of 2 proportions, since we are having all the employees together. I mean, evaluating them in between the same society. But that is why I think it was paired. But thinking it because it is just trying to get the treatment they got. I don't know if that one will be categorical or just quantitative.
Well, for me, this is either an independent sample t-test or the test of 2 proportions.
Yeah, I'm pretty sure it's not paired because the 2 samples aren't.
No, independent
upon each other.
Independent sample. But okay. Okay.
Okay.
I was just thinking it was. So what were we going with?
Proportions.
The test of 2 proportions.
Test of 2 proportions.
Okay.
So it says a survey was conducted by a group of state lotteries. A random sample of 2,406 adults completed the survey. Total of 248 were classified as heavy players. Of these, 152 were male. You want to determine if the proportion of male heavy lottery players is different than the proportion of males in the population, which is 48.5. Which hypothesis test would be the most appropriate for this analysis?
I was selecting the first in the 1 sample z-test.
I just don't really know.
Yeah, the thing that threw me off was how it talks about the they're looking for the different proportion of males in the population. And,
Right.
but I think you might be right that it.
See, I marked this one down as a test of true proportions.
Yeah. And it says you want to determine if the proportion of male heavy lottery players. So if we're having just one group, will be then just a test of one proportion.
So F, the test of one proportion.
So will be letter F. Okay, so this is number 4. A student project compared the effectiveness of 2 different combination locks. One of the locks turned clockwise first and the other lock turned counterclockwise first. They asked 25 students to participate in the study. Each student was given the combination to each clock and asked to open the locks. The time it took them to open each lock was recorded. They went to determine if one of the locks is easier to open, which hypothesis test would be most appropriate for this analysis. With this one, I was thinking that's a one sample t-test, or that's because we have just one.
See, I marked this as a paired sample t-test. This is similar to the when they were doing the 2 estimators for the one question where they had the 2 estimators who went out and estimated home values to see if they were the same. That was a paired sample t-test.
Okay.
That's how I view it. I could be wrong, but
I was leaning towards the paired sample t-test also.
okay.
Yeah, that makes sense.
Because you have the same people performing it.
Right.
Okay.
Okay, so questions 5 through 7, we're going to decide the confidence interval to use. So question 5, a bank employs 2 appraisers. When approving borrowers for mortgages, it is imperative that the appraisers value the same types of properties consistently. To make sure this is the case, the bank evaluates 6 properties that both appraisers have recently valued. Which confidence interval would be most appropriate for this study?
I marked this as paired sample T confidence interval again.
Yeah.
Yep.
Okay. So, in a Wall Street Journal article on satisfaction with career paths, the percentage of psychology majors reporting they were satisfied or very satisfied with their career paths was reported. The same day, so all data was also reported for accounting majors. You decided to construct a 95 confidence interval to see if the observed difference is significant. Which confidence interval would be most appropriate for the study? Independent.
So would this be the independent sample?
That's what I marked it as.
Mm-hmm. Yes. Okay, number 7 says double stuffed Oreo cookies are supposed to have twice the filling of regular Oreo cookies. You and some friends decide you want to know if that is true. If that is a true assertion by the company who makes them, you take a sample of 55 double stuffed Oreo cookies and measure the amount of filling in each one. You need to construct a confidence interval to estimate the true mean filling amount of double stuffed Oreos in order to compare it to the filling amount found in regular Oreos. Which confidence study would be most approved study? I was going with a paired sample since we have the same manufacturer and 2 different things to evaluate.
Okay.
Okay, so paired sample. Okay, so number 8, which one of the following best defines the notion of the significance level of a hypothesis test? Probability of rejecting null hypothesis when it's true or not, the probability of observing a sample statistic more extreme than one actually obtained, assume the null hypothesis is true, probability of a type 1 error, and probability of a type 2 error.
I got C for this one.
I was thinking B. I'm not sure.
B is your p-value definition.
Okay, I think I was getting confused.
And this is from from lesson 9 review. The value of alpha is the probability of committing a type 1 error.
Okay, perfect.
Type 1 error.
Good.
And alpha is your significance level, correct?
Right.
Okay. And then it's the same p-value. Where'd it go? Lesson 9 review as well. P-value is the probability of observing a sample statistic more extreme than one actually obtained, assuming the null hypothesis is true.
Yes, that's correct.
Which is B for number 9.
And it says for number 10, suppose you create a 95% confidence interval for a mean and get 10 to 20. You've been told to report this by saying something similar to we are 95% confidence that the true mean is between 10 and 20. Exactly what does this mean? And I was going with letter C. It says that there is a 95% chance that the true mean is between 10 and 20.
I went with
because yeah, we've had this one before, and I think or
95%. 95% of all 95% confidence intervals actually contain the true mean.
Yeah.
If we did this again, our confidence interval could be 11 and 21, or it could be 9 and 19 or 18. And so 95% of all 95 confidence intervals will actually contain the true mean, 5% will not.
Okay. Thank you.
So it's a D.
That's what I believe. I'm trying to remember which review session I read that in.
No, see, that seems familiar because I remember seeing this before somewhere and it being something like that.
Right. Okay.
All right. So 11 through 13, use the following information. You take a simple random sample of 100 adults from a town in the western United States to determine the proportion of adults in the town who invest in the stock market. Assume the unknown population proportion or percentage of people in town who invest in the stock market is 30%. So what is the mean of the distribution of the sample proportions?
So P just becomes your new
Yes,
U.
correct.
So it's 0.30.
Yeah, that's what I selected.
The standard deviation for the distribution of the sample proportions, that was standard deviation formula, P, the square root of P times 1 minus P divided by N. So square root of 0.30 times 1 minus 0.30 divided by 100. I came up with 0.0458 rounded to 0.046.
Okay, can you repeat once again the formula that you use? I didn't find the formula.
The square root,
Uh-huh.
and under the square root symbol is P times 1 minus P divided by N.
Okay, gotcha.
And that should have been in, that was lesson, where was that at?
I think it was lesson 3 or something.
16 or, I can't remember what it was.
I think 16.
16.
I understand. Lesson 16.
Yeah, standard deviation of P was, that's where it was at. It's in 16 review.
Okay, thank you. As I was trying to look it up. As number 13, it says, what is the probability that your random sample of 100 adults will have a sample proportion less than 0.25?
So this ends up being your z-score is your observed minus your mean. Divide that by your standard deviation formula, and then enter it and shoot to the left. It's left, correct? Does that all make sense?
Yeah, I think you're right.
Like I said, I'm just going back through my notes here. This is lesson 16 as well.
That would be it's that is z equal the value minus the mean divided by the standard deviation.
Yep.
Yes, that's from what I have in here.
And so P hat for this one becomes your 0.25. So Z equals P hat minus P, and then over that standard deviation formula we just talked about. So you get negative, or you get 0.25 minus 0.3 divided by 0.0458, a Z-score of negative 1.091. Enter that in and shade to the left.
It's really around, so listen. Correct, will be just the left side being shaded. So plus 1.
So when I did that, I ended up with a value of 0.138.
Yeah, that's how it comes whenever you put the z-score just having the left side being shaded. Since we're looking for less than.
Okay. Are we ready to move on?
Yes.
Yep.
Questions 14 through 18 using the following information. Acupril is meant to control hypertension. In clinical trials of Acupril, 2,142 subjects were divided into two groups. The 1,563 subjects in the experimental group received Acupril. The 579 subjects in the control group received a placebo. Of the 1,563 in the experimental group, 61 experienced dizziness as a side effect. Of the 579 subjects in the control group, 15 experienced dizziness as a side effect. Let P1 be the true proportion of people who experience dizziness while taking Acupril. Let P2 be the true proportion of people who experienced dizziness but did not take Acupril. Create a 95% confidence interval for P1 and P2. So for this one, I went right to the Excel spreadsheet, plugged the numbers in for X1 and N1 and X2 and N2. Plugged in that I wanted a 95% confidence interval. And my answers were E, the negative 0.003 and 0.029.
Yes. That's what I came up with.
Okay.
So then number 15 says, which of the following pairs of hypotheses is the most appropriate for addressing this question? And I selected option B, that the null has P1 equal to P2 and the alternative P1 not equal to P2.
That is what I put down as well.
Okay, 16, the value of your test statistic is
I came up with option D, 1.458.
That's what I came up with as well. Which led me to a p-value of 0.145, which was D. In
Yes.
dog.
Correct. So then it says, number 18, is there sufficient evidence to conclude that the true population of people who experience dizziness while taking Acupril is different than the true proportion of people who experience dizziness while not taking Acupril? And since the p-value is greater than the level of significance, it's letter E. No, I failed to reject the null.
That's what I put.
okay. Question 19 to 22. Use the following information. Survey was conducted of 1,279 randomly selected adults aged 18 and older. They were asked, are you a morning person or a night person? So your null hypothesis being a morning or evening person is independent of age, and the alternative being a morning or evening person is not independent of age. Then the results have 19, calculate the test statistic for the hypothesis test. Assume the requirements for the test are satisfied.
Came up with option A as 6.580.
That's what I came up with as well. But did either one of you notice that the numbers in the box don't match the numbers in the question in the written format? When you input your data, where'd it go here? Let me get back to it. Where's that? That's it. I end up with a total sample of 1,382, not 1,279.
Let me go back to that one.
I double checked to make sure that I had all the entries there. It's just,
Yeah, you're right. I didn't check the total, but yes, it says 1392. It's different.
13. Huh.
Yeah, I think that is why it's advised in for us to assume that the requirements are satisfied.
okay. I just noticed that while I was doing it.
Good point.
It says calculate the p-value for the hypothesis test. Assume the requirements for the test are satisfied. P-value I had 0.866, which was C.
Yeah. Right.
Let me just double check p-value. Yes, that's the one. Then 21 says, should you reject the null or not and explain? Come up with option E. No, we do not reject because the p-value is greater than 0.05.
Right.
That's what I put as well.
Okay. Do you have sufficient evidence to conclude that age makes a difference in whether a person is a morning or night person? Why or why not?
I was going with option F. What is the no? Because we failed to reject.
That's what I put as well. I think the D is a trick question, a trick answer.
Yeah.
Kind of, yes.
Okay. So question 393 and 29, use the following information to answer each question. Recent book noted that only 20% of all investment managers outperform the Dow Jones Industrial Average over a 5-year period. Random sample of 200 investment managers that have graduated from one of the top 10 business programs in the company were followed over a 5-year period. 50 of those outperformed the Dow Jones Industrial Average. Let P be the true proportion of investment managers who graduated from one of the top 10 business programs who outperformed the Dow Jones over a 5-year period. So in this case, for me, you had your original P was 0.2. That's your P star is 0.2 for the 20%.
Yes.
And P hat equals X divided by N, which is 50 divided by 200, which is 0.25.
Correct.
Based on the results of the sample, a 95% confidence interval for P is C, 0.190, 0.310.
Yes.
And this was a one sample Z test for a proportion.
Correct. So 24 says, suppose you had been in charge of designing the study, what sample size would be needed to construct a margin of error of 2% with 95% confidence? Use a prior estimate of P equal to 0.2 for this estimate. So I just used the formula N equal to the 1.96 divided by 0.02 to the square, and then that multiplied by 0.2 times 1 minus 0.2, and I came up with 1536.64, just rounding it to grand total to 1537.
I ended up with 15.68.
1568?
15.68.
Oh.
Because you have your Z score 1.96 divided by 0.02.
Yeah, all that to the square.
Yep, that could be where my problem is right there. Once again, I get decimals 0.2. Let me recalculate. You're probably right. Just let me double check it, please.
Okay. Sure. I just round just until the end.
Yeah. 1.96 divided by 0.2. Square that times 0.2. Square that times 0.2 times minus 0.2. I still end up with 15.366. So if you round that up, it's 16.
Let me just go ahead and do so again. At 1.96. 1.96 divided by 0.02, that's 98.
It's 0.2, not 0.02.
But since
Right,
the
'cause it's
margin
20
of error is 2%, because the formula is having the 0.96.
Right. So even
Oh, you're right.
I had it written down correctly the first time. Not where am I getting
Yeah.
0.2? That's where.
I think you were looking up at the top.
Yep.
Where it was
But
20%.
so I had it written down right the first time. That's where my margin of error was 0.02. Right?
Mhm.
Okay,
Yes.
go ahead and work your way through it again.
1.96 divided by 0.02, that's 98. That to the square, that's 9,604.
Right.
So then we need to have 1 minus 0.2, that multiplied by 0.2, that's 0.16, and we multiplied 0.16 times the 9,604, come up with 1,536.64.
Yep.
Yeah, so I ended up with the 1536.64.
Yeah,
That to
it's just
1537.
Yep.
yes.
Okay. That extra point decimal makes a difference.
Certainly it does, and a lot.
Okay.
Okay,
I
so
don't even know. So suppose you wish to see if there's evidence that graduates in one of the top business programs perform better than other investment managers. Conduct a hypothesis test using level significance of alpha equals 0.05, which of the following pairs of hypotheses is the most appropriate for addressing the question. I chose C.
yeah,
Null hypothesis P equals 0.2, and your alternative P is greater than 0.2.
yes.
Okay.
But then for tuna success, how many measurements must you have in order to assure that p hat is normally distributed? I was going with C as well. N times p equal or greater than 10, and n times 1 minus p equal or greater than 10.
That's what I had as well.
So the value of your test statistic is
Come up with letter A, 1.768.
That's what I have. The p-value is 0.039.
Correct. Option B. And it says 29. Is there sufficient evidence to conclude that graduates from the top 10 business programs perform better than other investment managers? And I selected option A, we reject the null.
That's what I chose as well.
Yep. All right. Question 30 to 33. Computer software is commonly used to translate text from one language to another. As part of his PhD thesis, Philip Cohn developed a phrase-based translation program called Pharo. Quality of the translation can vary. A good translation system should match a professional human translation. It is important to be able to quantify how good the translations produced by Pharo are. The IBM T. Watson Research Center developed methods to measure the quality of a translation from one language to another. One of these is the bilingual evaluation understudy, or BLEU. BLEU is a score ranging from 0 to 1 that indicates how well a computer translation matches a professional human translation of the same text. Higher scores indicate a better match. BLEU helps companies who develop translation software to monitor the effect of daily changes to their systems in order to weed out bad ideas from good ideas. To compare Pharo's ability to translate with similar computer translation software, Cohn took a random sample of 100 blocks of Spanish text, each of which contained 300 sentences, and used Pharo to translate each of these to English. The BLEU score was calculated for each of the 100 blocks. Cohn used this data to see if it differs from the mean BLEU score of another leading translation software, which has a population mean score of 0.295. Open the data, the BLEU score.
Before we go any further, I identified this as a one sample t-test. Did anybody else?
I think that's the one I used. I don't remember. I just wrote down the answers.
All
right. Yep, that's the one.
Okay. So, assuming that the requirements are satisfied and calculating a 95% confidence interval for the mean of the BLEU test score, my confidence interval was 0.282 and 0.293 for the upper.
Yeah.
Said 0.282 and 0.293?
That's what I had, yes.
Okay, that's what I got also.
Mm-hmm. Then the next one says 31 calculated degrees of freedom in the test statistic for a test of null equal to 0.295 against the alternative not equal to 0.295, so the requirements are satisfied. So the degrees of freedom were 99. And then the test statistic was for 1.768. No, sorry. It's not this one. It's the other spreadsheet. That one is the z-score. I come up with a negative 2.803.
Negative 2.803 is what I had as well.
Yeah.
I'm sending a text off to my. Give me just a second here.
What was that number you said again?
It's negative 2.803. And then the test statistic, well, that's a test statistic in degrees of freedom being 99.
Right, yeah.
Sorry, I'm trying to let my next class know that I'm running along here, and that if they want to start without me, I'll get with them when I can. Just give me just a second.
Okay.
Okay, I'm back. Thank you.
You're welcome.
So for the p-value, did you get 0.006?
I did.
Yeah. Mm-hmm.
And then based on the results of the test, what would you conclude using a level of significance of alpha equals 0.05? Value is less than alpha. So we have sufficient evidence to say that the true mean is different than 0.
Correct.
Oh, so that'd
Option
be D,
D.
right?
Yes, option D. And then it says questions 34 and 38. Use the following information. A study was done to test the notion that people are taller when they first wake up in the morning than in the evening right before they go to bed. To test this theory, the heights of children in a boarding school in India were measured. Values were recorded in millimeters for each child in the morning and again in the evening. You want to determine if the children are taller in the morning than in the evening. Use the file and define the differences as AM heights minus PM heights. And it says give a 95% confidence interval for the true mean difference of heights. And it says you also want to conduct a hypothesis test to determine if there is a decrease in heights from morning until evening. Use a level of significance of 0.05. Then it says the confidence interval that I'm coming with. That's 0.190 and 0.1310.
I came up with 0.8728 and 10.455.
455. I think I used the wrong one, but let me just double check.
Still trying to pull it up.
Because this one was the two independent sample, right?
Isn't this paired sample?
It's paired sample. Okay, I was using
I would
the
say paired example.
independent. Let me just switch it then to the paired sample. One second. Yeah, then the confidence interval is as you just said, Sean. Sorry, it is the 8.728 and then 10.455.
8.728 and 10.455, right?
Yeah.
So the degrees of freedom, or wait, we're on 35. Oh, test statistic was, I got 22.446.
Yes.
So that was a paired sample t-test, correct? And
Yes.
And the T score was 22.446.
Mm-hmm.
For degrees of freedom, I got 40.
40. Yes.
P-value has a whole lot of zeros out in front before you get into where there's any true integers.
Right. Yeah. So just
Yeah, so
0.0000.
Yeah. With that being said, we go with option A because we reject the null.
Right. Okay.
Yep.
Okay. So then we can move on to the question. Let's start with right to participated. So do you have it ready?
I'm ready.
Great. So for the first one, it's the one for the Korea. We selected it was an independent sample t-test.
Right. I got
The next
numbers
one.
off. That throws me off a little bit.
The second one we selected it was a test of two proportions.
Right.
Next one. Next one we concluded was the one proportion test.
Yeah.
Next one. And as we concluded was a paired sample. Paired sample t-test.
So this is a student.
First. Then for question 6, we also decided it was a paired sample.
Right.
For 7, we decided for number 7 it was an independent sample. For the next one, the next one was the paired sample as well.
Right.
For number 9, we decided that it was the probability of type 1 error, correct?
Correct.
For 10 was the probability of observing a sample statistic more extreme than the one actually obtained, assuming the null hypothesis is true.
Right.
question 11. Then we concluded was the 95% of all 95% confidence intervals actually contain the true mean in the second option. 12 came up with the mean being 0.30. Then it says question 13, what is the standard deviation? We came up with 0.046. Then the probability being 0.138. And question 15 asks for the margin of error. So let's go ahead and find the margin of error. So we have 0.029 minus 0.003. Then dividing that one by 2, I got 0.013.
Okay, I'm sorry. Walk that again.
Since the interval is negative 0.003,
Right.
and then 0.029.
Right.
So
this is actually a question that was on the review. This is just another one. Correct?
Yeah. Yes. Because in the review was asking for just for the interval, but in here it's asking for the margin of error.
Margin of error. So you take the upper 0, upper minus lower, divide by 2.
2, yes.
0.029 minus negative 0.03.
I get 0.016.
Yeah, it's 1/6, sorry.
Yeah.
It's 0.016. Then the next one is asking us for the lower bound, which is negative 0.003.
Almost forgot the negative then.
Yeah.
Okay, so you guys came up with 0.016 for the margin of error, correct?
Yes.
Right.
All right, lower bound, negative 0.003.
Then the upper one, 0.029. Number 18 came up with, and here will be the first option.
Right.
Null having p equal p2, and then alternative p1 not equal to p2. And the next one having the value of the test statistic, it was 1.458. The p-value was 0.145. Then 21 is that we fail to reject the null, which is the last option.
No, I failed. Let's reject the null.
And the next one says calculate the test statistic. It was 0.580. The p-value was 0.0866. Well, but just let me double check with this one. Because when you just run into 3, third, then it will be 0.866. And that's the next one. So now the p-value is greater than 0.05, which is the
What's that? Number 23, what was it again? 0.086? Was that what it was?
0.866.
Yeah, 0.866. So the next one is the fourth option, because
Sorry, I'm
now
just looking at the spreadsheet for that one with the test statistic of 6.579, but then the p-value says 0.0866.
Let me go to the spreadsheet back again just to double check.
Sorry. Yeah, I still had it up, and I just want to make sure.
That's a very similar number.
Yep, so it comes to 0.087.
Yeah. Will be 0.087. Thank you, Harry. It's just a decimal making the difference. Okay, so the next one is the fourth option. Now the p-value is greater than 0.05. Then the next one, what do you conclude? It says that this one I am going with
So we rejected.
So will be the fourth option. We have insufficient evidence to say that being a morning or evening person is not independent of H.
Right. No, we have insufficient evidence.
To say that being a morning or evening person is not independent of H.
Back up and read the question again.
Yeah.
Being a morning person or evening person is not independent of age.
Yeah.
We have insufficient.
Reject that.
Remember, because the alternative hypothesis states that they are not independent. It says being a morning person or evening is not independent of H. So the null is being a morning or evening person is independent of H.
Do we have sufficient evidence to say that being a morning or evening person is independent of age?
We have insufficient.
We failed to reject the null.
Yeah.
Mm-hmm.
So we have insufficient evidence to say that being a morning or evening person is not independent of age. I don't know. I hate the way they word these stupid questions.
I know.
Say that being a morning or evening person is
Who speaks like this?
But let me go to the
Who speaks like this?
being a morning or evening person is independent of H. Because the alternative says being a morning or evening person is not independent of H. And since we failed to prove that, so that is why we say we have insufficient evidence to say that being a morning or evening person is not independent of H.
Okay.
We have insufficient evidence to prove this statement.
Yep.
For next one, this one is asking us for the lower bound. For this one, I have 0.190.
Okay, so what question are we actually on the homework?
26 on the quiz.
Right.
Yeah.
What does that translate into?
23.
And on the review is 23.
All right. Zero point
Yeah,
one.
0.190, yes. Then the upper bound, 0.310. So then the next one is asking us the total sample, which is 1,537.
Right.
And the next,
7.
yeah, it's 1,537. So for the next question, I would go with the fifth option. Null having p equal to 0.2 and alternative p greater than 0.2. Next one will be the first option.
Right.
N p equal or greater than 10 and n times 1 minus p equal or greater than 10. Then the value of the test statistic I am coming with 1.768.
Right.
P-value of 0.039. Then it will be the first option. Yes, I reject the null. And going to question 34. The lower bound is 0.282.
.282.
On the upper bound, 0.293. Yeah, 293. Then it says input the degrees of freedom.
99.
Yeah, those are 99. Then the test statistic is negative 2.803.
Negative 2.803.
Yeah. Then the p-value being 0.006. 39. That's
the first option.
If you notice that treatment is different, then yeah, that will be the first option. Then going with the next one, it says the lower bound, it got 8.728. And then the upper bound for 10.455. The test statistic for 22.446. The grace of freedom 40. And then p-value of 0.000. And the last one will be the third option, yes, because we rejected the null.
Perfect.
Let's submit it and let's check how it goes. We missed question 2. We missed question 7. Question 8.
So question. So hold on a second here. So question. So question 2 is really our question 1. It was not an independent t-test.
So we missed 3. It was question 2, 7, and 8.
Which is 1, 6, and 7 from the homework.
It was not a 1 independent sample t-test. All right, so this is question 2, 3, 4, 5. So question 3 was a test of 2 proportions. Question 4 was a test of 1 proportion. Question 5 was a paired sample. Question 6 we put paired sample confidence intervals. That was correct. 7 independent sample confidence. It was not. Okay. Question 8 was not paired sample. Question 9 was the probability of committing a type 1 error. Question 10 was the probability of observing sample. Alrighty. Question 11 11. 95 of all 95s was correct. That's correct. Question. 0.046 was correct. And 0.138 was correct. Margin of error was the 0.016. Okay, 16. Plug in before my computer dies. Excuse me. That was correct. And that was correct. So both of those were correct. What a pain this quiz is.
It's very long.
1458 is correct. Kevin, did we miss any other ones?
No, just the
Just those
two,
first ones?
2, 7, and 8. But for the review, bin 1, 6, and 7.
Okay. Okay. So 25 was the one that was a little bit, we have insufficient evidence to say. Right.
Yep.
Okay. I guess we go back and hash out the other ones then.
Yeah. If you would like to, we can go ahead and discuss the others.
All right. So let's go back and should we start over and just discuss them while we're doing them?
Okay.
You all right with that, Kerry?
Yep, sounds good.
Hopefully I don't make any errors and mistakes this time as I get my fat fingers typing like I did last time.
Hopefully no.
I think I had a worse score the second time than I did the first time because I typed something wrong.
Oh no.
Okay.
Right.
Now let's read again the second one. It says, in an article in the Journal of Small Business Management, successful startup businesses in the United States and Korea were compared. One set of data compared educational level, high school, undergraduate degree, master's degree, and doctoral degree. of people who manage successful startup companies in the United States and Korea. You want to determine if educational level of managers of successful startup companies is independent of the country they are from, United States and Korea. Which hypothesis test would be most appropriate for this analysis? So since this is not the one we selected, it's not an independent sample test, and it's not paired.
I still think it has something to do with all of the different
Yeah.
education levels, which would be an ANOVA.
No.
I mean, did you guys see the flow chart in at the end of the video for lesson 19?
I think I saw the video from.
I didn't check the videos for that week.
So it talks about when you have 3 or more samples, it goes to an ANOVA. The problem is it only because there's 2 samples?
Yeah, 2 main samples, and then we have 4 different options within those samples. Do you think as well could be the chi-squared option? Because on that one,
That was the only other thing I could think that it would be.
because in the chi-squared, yeah, because the ANOVA, it's for different, more than 2 means, but in this one we have like the main one and subcategories on each sample.
Okay.
So I'm thinking as well that could be the chi-squared, because on that one we have the main group and then the small ones.
Right. I agree. I think it is the chi-squared.
Okay.
If you want, we can try with that one. I mean, that's what I'm thinking. Based on what, if we analyze it that way, we have 2 main and then 4 different subcategories in each sample.
Right. Okay. That makes sense.
Okay. Then the next one we missed was.
Okay, so just so that I'm following along here, make sure I'm getting these done.
Okay.
So the second one, we're choosing chi-squared.
Right.
Yeah.
Question 3 is now still G.
Test of 2 proportions.
Test of 2 proportions.
Next one is test of 1 proportion.
So test of 1 proportion.
And next one is a paired samples t-test.
Okay, so 6.
6 is the paired samples t confidence interval.
Okay.
And the 7 is the one we need to discuss. It says, again, in a Wall Street Journal article on satisfaction with career paths, the percentage of psychology majors reporting they were satisfied with their career path was reported. The same data was also reported for accounting majors. You decided to construct a 95% confidence interval to see if the observed difference is significant. Which confidence interval would be most appropriate for this status?
So what I didn't read, I guess, here before was we're talking about percentages, right?
Yeah, and if they are feeling okay or not.
So confidence interval of 2 proportions.
Yeah, that's what came to my mind.
Okay.
I selected. Yeah.
So
the next one.
This should be question 7, right?
Sorry?
This should be question 7.
Yes.
Confidence interval of 2 proportions.
Correct. Next one says, double stuffed Oreo cookies are supposed to have twice the filling of regular Oreo cookies. You and some friends decided you want to know if that is a true assertion by the company who makes them. You take a sample of 55 doubles of Oreo cookies and measure the amount of filling in each one. You need to construct a confidence interval to estimate the true mean filling amount of double-stuffed Oreos in order to compare it to the filling amount in regular Oreos. Which confidence interval would be most appropriate for this one? We selected it was a paired sample, but
Would this one just be a one sample? Because right now we're just doing the double stuff.
Yes,
You want to figure that out?
That's my thoughts on this one, because looking back at it now, you're going to have something to compare it to, which is a one sample, and then you'll put it in to see if it.
Okay, so then the one sample T confidence interval?
Sure.
Okay. Okay, number 9 is the probability of type 1 error.
One sample T confidence interval. Save.
Yeah, so then moving on, number 9 is the probability of type 1 error. Number 10 as the third option, the probability of observing a sample statistic more extreme than the one actually obtained. Number 11 as the second option, 95% of all 95% confidence intervals.
95% of all 95%, second option.
12 is 0.30. 13 is 0.046. 14 is 0.138. Then 15, number 15 is 0.016.
Do you have to put the zeros in front of the decimal place on this one?
I'm putting that in there.
I put them on, but I don't think it matters.
Because 0 doesn't count.
What's that?
Because 0 to the left doesn't count. So 0.016 is 0.016. I'm pointing the 0 just if in case.
I think
so then number 6.
Have it and not have it, and it doesn't make a difference.
All right, so we're on question 15, correct?
Yeah, 15 is 0.016. Question 16 is negative 0.003.
Negative
0.003.
0.0.
Then 17 as 0.029. Then question is 18 is the first option. P equal P2 and then P1 not equal to P2. Number 19, it's 1.458.
Hold on a second. Okay. 1.458.
Yeah. P-value for 20 is 0.145.
Hold on. It's what? 0.145?
Yeah. Then 21 is the last option. No, I failed to reject the null.
The last option. No, I failed to reject the null.
For number 22 is 6.580. For question 23 is 0.087. Then for question 24 is the fourth option. No, the p-value is greater than 0.05. Then 25th is the last option. We have insufficient evidence to say that being a morning or evening person is not independent of age. 26 is 0.190. Then question 27, 0.310. Question 28, that's 1537.
Hold on a second.
Then, okay.
My other class is trying to submit something as well, and they want me to just look at something. If we can hold on for just a second.
Okay.
You know, I don't have time to do that because I have to download a bunch of Apple software that I don't have and don't use. So, okay, so 28 here. 28 is, what did we decide? That was the 15.
1537.
If it was something easy, I could just respond to them, but I don't have the, I don't use a Mac, so I don't use half the stuff that they use.
Okay, for 29, as the fifth option going down, P equal to 0.2 and P greater than 0.2. Then 30 is the first option, and P equal or greater than 10, and n times 1 minus P equal or greater than 10. 31 is 1.768.
1.768.
And the next one, the p-value is 0.039. The next one is the first option. Yes, I reject the null. Next one, 34, 0.282. 35 is 0.293.
0.282. 35.
Yeah, 35, 0.293.
0.2.
36 is degrees of freedom, being 99. And 37 is negative 2.803. P-value is 0.006. Next one is the first option. We have sufficient evidence to say that the treatment is different than 0.295. Question 40 is 8.728. Then question 41, 10.455. Question 42, it's 22.446.
22.446 for 42.
Yes. Then for 43, it's 40 for the degrees of freedom. 44 is 0.000. And 45 is the third option. Yes, because we rejected the no. And let's check if what happened with 2, 7, and 8. Okay. 2 is correct. For 7, we got 7 as well, and we got 8. So then we got them all.
Nice.
100.
Perfect.
That looks good, finally.
Yep.
That was a very, very long quiz. It's almost 2 hours in conversation, though.
Yep.
Go team.
That's right.
But finally, we figured it out. So good luck, guys, on your test. That's due tomorrow.
And don't forget to take your test.
Right.
Yeah.
Absolutely.
So then have a good night then.
All right.
Alrighty.
Thanks, guys. Appreciate it.
Have a good night.
So then just one last question. Do you want to meet on Yes, do you want to meet on Thursday just to discuss if we got a response
Yeah, that'd
from
be
the
great.
design study? So then we can do the next part, which is do this coming March 24th, which is the part of collecting the data.
Yep, I'll go back and try to get that submitted tonight. You got it.
Okay.
Yeah, perfect.
Thank you, Sean. So then see you on Thursday. Have a good
All right.
night.
Bye-bye.
Bye.
Okay.